every region of the planet, work towards new, clean energy sources seems more important and more pressing than ever. According to the report, many of the changes observed in the climate are unprecedented in thousands, if not hundreds of thousands of years. But it also says that strong and sustained reductions in emissions of carbon dioxide, CO2, and other greenhouse gases would limit climate change. So, there is still a chance to alter course, and many countries already have targets in place to cut the harmful emissions driving these unwanted changes to our planet. Fusion power plants could provide a powerful ally in reaching the ambitious emission reduction targets required. Equally ambitious are the fusion experiments underway that may lead to this hoped-for new generation of power plants. The largest of these is the ITER, the way in Latin, experimental reactor, being built in Cadarache in southern France. This has 35 nations pooling funding and scientific expertise, including the 27 member states of the European Union, plus Switzerland and the UK, China, India, Japan, South Korea, Russia, and the United States. ITER will never generate electricity, but it aims to demonstrate all the scientific and technical steps required to build commercial fusion energy power plants. While ITER is by far the biggest of the multinational projects attempting to harness nuclear fusion for electricity generation, it is by no means the only contender in the race. Many countries have, or have had, their own research reactors. These include the Joint European Torus, JET, at the Culham Centre for Fusion Energy in the UK, which was first fired up in 1983. The now decommissioned Tokamak Fusion Test Reactor, TFTR, in the United States, which broke several records during its 15-year lifespan. The Chinese Fusion Engineering Test Reactor, which was powered up in December 2020, and the Korea Superconducting Tokamak Advanced Research, K-STAR, project. K-STAR is a pilot device for ITER and, as we will see later when we look in more depth at these projects, set a new world record in November 2020 for one of the key stages in fusion reactor development. Then, as we will also explore, there are the private companies fielding fusion contenders. Some of these have high-profile backers and collaborators, such as Canadian company General Fusion, which has funding from Amazon's Jeff Bezos, and TAE Technologies, which is in partnership with Google. Not all of these projects are taking the same technological approach. As we will discover, there are different ways in which nuclear fusion reactions can be triggered and then contained, and multiple variants on the main approaches. No one is yet sure which approach will win out, or indeed, if a range of methods will be needed to help secure our future energy needs. Along the way, the reactors look set to become spectacles in themselves. The sheer scale of ITER's reactor, for instance, with its 1 million components, weighing in at a combined total equivalent to the weight of 3 Eiffel Towers, is difficult to envisage. Meanwhile, General Fusion has employed award-winning architect Amanda Levette, whose practices previous commissions include the International Olympic Committee headquarters in Lausanne, Switzerland, to work on the design for their prototype power plant near Oxford in the UK. Yet it's not just power stations that are on the cards. There is the potential for fusion-driven rockets to provide the transport for future interplanetary travel, including missions to Mars, and various technologies developed to help enable fusion energy studies to progress, such as the advanced robotic systems we will hear about in Chapter 7, have applications in other research or industrial settings. But the main goal of most fusion projects is to generate clean, sustainable power for our planet. From the physics breakthroughs of the early 20th century that revolutionized our understanding of atoms,